Hello students, my name is Arun Kumar. I'm going to be teaching CSE132C database system implementation in Spring. So in this video, I will give you a brief overview of this course. A little bit about myself to start with. I did my undergraduate degree in computer science and engineering at the Indian Institute of Technology, Madras in Chennai, India. And that's the Marina Beach over there in Chennai, one of the largest urban beaches in the world. So I grew up with the beach. And then I went to Madison, Wisconsin for my graduate school in the database group at the University of Wisconsin. And so I did my thesis on data management and systems for machine learning workloads. And that picture over there is the beautiful State Street and the Capitol building. And I joined UC San Diego Computer Science and Engineering in 2016 fall, right after graduating with my PhD. And since 2019, I'm also jointly affiliated with the Halajulu Data Science Institute, HDSI. So what is 132C about and why would you want to take it? As Victor has probably explained to you already, large-scale data management systems are the cornerstone of many digital applications, both traditional and modern. And by traditional, we typically mean enterprise applications like retail, banking, finance, telecom. Even domain sciences are now very data intensive. So that picture is from the Large Hadron Collider, the largest data firehouse on the planet. And more recently, even web companies are very data intensive. So here on the left, you have Google's structured data extraction, the Knowledge Vault project, where they populate info boxes, which are relational structured data extracted from text. On the right, you have one of the more popular recommender systems, Netflix, where they store huge amounts of structured data for processing and making predictions. Our primary focus in this course is going to be on the relational data model. So two-dimensional structured data that have well-defined schema and relational database management systems that implement the relational model, RDBMSs. Just to put this in context, in Victor's class 132A, you're going to be covering you probably have covered already the principles of the relational model and relational algebra, the operators, and also SQL. In 132B, you would dive deeper into SQL with more application database kind of features and capabilities. And in 132C, you will peel the curtains and look behind the scenes. What happens in an RDBMS, what magic takes place that converts your SQL query into code that exists, that executes on the database. Here's a diagram from a textbook. This is what an RDBMS looks like. It has multiple components to convert your SQL query into code that executes on the data files that sit on your secondary storage disk. Okay, so we'll walk through each of these components in the CSE132C, starting with the lowest level, which is the storage through the memory management, through file management, through query evaluation and optimization. To be more precise, CSE132C will get you to think critically about the implementation of database systems. And I split this into 4 main components, roughly aligning with 4 parts of the quarter. Number 1, how are large structured data sets stored and organized? Number 2, how are queries handled? Number 3, how to make the queries faster and more scalable? And number 4, some recent developments and trends. Specifically, we will cover number 1 in the topics of data storage, file organization, and buffer management, how to lay out relational data, and how to exploit the memory hierarchy better so that we utilize resources efficiently. How are queries handled? We'll talk about secondary index structures, we'll talk about secondary data structures such as indexes, external sorting, relational operator implementations. How does a join work at scale, for example, and query processing? How do you stitch these operators together to create pipelined execution plans? How to make it faster and scalable? We'll talk about query optimization, both at the logical level and the physical level. So at the logical level, we'll utilize the semantic properties of the relational algebra operators. Stuff that you're learning in Victor's class will be necessary there. Then we'll also talk about at the physical level, how do we compare alternative execution plans of queries? And then we'll talk about scalability and parallelism. How do we scale this out to enormous quantities of data on a machine cluster using parallel relational DBMSs? Recent development and trends, we'll talk about data flow systems, a new class of data management systems that have taken off in the last half a decade to a decade. We'll talk about Hadoop MapReduce and Spark and how they are related to parallel relational DBMSs. And then we'll talk briefly about so-called NoSQL systems or key-value stores, machine learning systems that have emerged in the last few years for large-scale machine learning workloads. And if we have time, I'll also talk briefly about applications of machine learning inside relational DBMSs for optimizing and improving DBMSs for everything from data layout to access patterns to caching and query optimization. More precise outline, and this is tentative, but this is sort of what I've been using for the last several years. I've been teaching this class. One difference compared to what I taught in the last year was the topic of transaction management has been dropped, and I'd like to bake in a lot more interaction activities in the remote edition so that students feel connected and are engaged rather than covering more material. If you are interested in the transaction management topic, I will happy to send you links to my lecture videos from last year's. Note the exam dates: midterm exam and final exam. These dates are fixed. The other activities and other components we'll talk about shortly. There's going to be a couple of guest lectures from industry as well. Prescribed textbook. This is the book I'd like to recommend, Raghu Ramakrishnan and Johannes Gerke, also from the University of Wisconsin. And it's also called the Cow Book. If you're interested, you could also use the complete book from the Stanford folks as an additional reference. Prerequisites, you're already taking this class 132A, that suffices as a prerequisite. Alternatively, if you have taken the CSE102, that also suffices as a prerequisite. These two are stuff that the CSE staff can enforce. If you have taken an equivalent introductory database class elsewhere at another department or another university, feel free to submit a waiver request via Easy or email me with sufficient details. Send me a transcript and such. If you have not taken any of these database classes, but you have substantial real-world experience with relational DBMSs and SQL, include that description, include your CV, and then submit a waiver request, and I'm happy to look into it. CSE120 operating systems and 132B applications, database system applications, are potentially helpful, but are not necessary to take this 132C. However, C++ is necessary because that's what we will be using for programming projects. If you are rusty with your C++ knowledge, there are programming references that I've linked to from the course webpage. These are the links are down there. The Spring 21 link is not populated yet, so the webpage is not up yet. I will do that in the next couple of weeks. The Spring 20 link is live, so you could go have a look at it there. Here are the components of this course's grading, learning evaluation. We have 2 projects, 2 exams, 4 quizzes, and a bunch of peer evaluation activities. The quizzes, exams, and peer evaluation activities are all going to be on Canvas. They'll have time windows of up to a day. All these Canvas-based activities are open books, open notes, open internet. Only thing is you cannot give help to anyone or take help from anyone. It's individual. Now, the peer activities are a new component that I've introduced in my DSE 102 this winter, and I will give more details about this in my introductory lecture, but feel free to take a look at the DSE 102 webpage down there to know what these are. They typically take the form of you discussing with your peers and then submitting some write-up, an essay on Canvas, and your peers will rate your essays. Okay, so basically it's a peer-to-peer kind of evaluation activity. The main purpose of that is to get you to kind of interact with your peers, get to know the class, and feel connected in this remote environment where we don't get to see each other, which really sucks, but we are stuck with it until at least fall. Here's a grading scheme. I don't like grading on curves, so I use an absolute grading scheme, and there are absolute cutoffs that I've listed over there. The learning evaluations are tailored towards the learning outcomes of this course, and I will go into details of the learning outcomes in the introductory lecture. And the relative bins are there as a safety net to catch in case people fall through. And so what I would do is take the better of either of these grading schemes, and then that will be a final grade. For example, if you score 82 as your total by the end of the class, and you fall as the 33rd percentile, the relative scheme will give you a B minus, the absolute scheme will give you a B plus, and so the final grade will be B plus. What this absolute grading scheme means, if you do really well, you can get a high grade even if everybody else does whatever they want. So if the entire class is doing really well and they're putting in the effort needed to learn the material and show that they have learned it, then the entire class can get an A grade. I'm not opposed to that. Okay, so programming projects, a little bit more detail. We'll be using an RDBMS skeleton in C++ from the University of Wisconsin again, called BadgerDB. You will be asked to implement a buffer manager and a B plus tree index structure on BadgerDB. With the APIs given, we'll tell you which functions you have to implement. It's via teams of 2 or via teams of 1, which is individual. No sharing of code across teams. Don't post code or search for code online. I take academic integrity very seriously. I will not hesitate to give you a failing grade or report you to the university or take other disciplinary action in case I find any cheating taking place. And this also applies to the exams and the other components that are individual only. Okay. No late days for programming project. You have to note down the deadlines, plan well ahead of time, and execute scrupulously. Finally, administrivia, we will be using Canvas and Zoom as mandated by the university. Piazza is available optionally in case you want to use that as the discussion board. The lecture slot is Tuesday, Thursday, 2 to 3:20. I will lecture via Zoom live, and then I will take Q&A live. There'll be breakout rooms and such. All of that will be recorded and posted to Canvas Media Gallery after the class. There's also a discussion slot, Wednesday 2 to 2:50. We will use this for review discussions before the exams. I will do the discussion sessions. The TAs will also do the discussion sessions for the programming assignments, give a talk on each project. And that means we will not be using all of the discussion slots. Only some of them will be used, and we will announce which ones. Canvas discussions is also available for you. So if you don't want to use Piazza, feel free to use Canvas discussions. I will replicate all course announcements across both Canvas and Piazza. All Zoom links are posted on Canvas, so you have to look that up. If you're not on the Canvas roster, you will not be able to access the course materials for quizzes and exams. So make sure that you will be on the Canvas roster by the first week of classes. Don't make Zoom links public, of course. We don't want Zoom bombing in this class. The last thing is, because we have absolute grading scheme, feel free to help out your peers by answering their questions, help out by kind of pitching in on exercises and other discussions for kind of before the quizzes and so on. And it gets more activity going so that you can learn together and learn from each other as well. Okay, so that's a wrap. Feel free to send me any questions via email and ask if you satisfy the prerequisites or something like that. I hope to see a bunch of you in my CSE132C in spring. All the best for your finals and the rest of this quarter. Take care.